Good afternoon, students. In the nuclear chapter, we are discussing numericals, textbook exercise problems. Yesterday, I think 13.6th problem. Check your notebooks. So already I have given question A given in the radioactivity problem. 13.7 AB, two questions are there. In that one question already I have solved here. And the second question B part, I think I have given homework. So check that question B. 13.7 B. 13.7 A already completed, I think. And B question, what they asked, a radioactive sample has a half-life of T years. How long it will take to reduce to 1% of the original value? So that is a B question. So 1% of the original value means n is equal to 1% of n naught, or we can write n by n naught is equal to 1%. So which is equal to 1 by 100 we can write. So half-life already given. So half-life of the radioactive sample is equal to the given capital T. Half-life of the sample is equal to capital T. Then what is the time? How long it will take? That you should calculate. Use the formula n by n naught is equal to 1 by 2 to the power of small t by capital T. 1 by 2 to the power of small t by capital T. Here this place you should write 1% means 1 by 100 is equal to 1 by 2 to the power of small t by capital T. Taking a reciprocal on both sides. So we can write 2 to the power of small t by capital T is equal to 100. But here 100 we cannot write 2 powers. Like 2 power 2, 2 power 3 we cannot write. That's why take a log on both sides. I'll take a log 2 to the power of small t by capital T is equal to log 100. So if you take both sides, if you take for example 10 or e, total meaning may not be changed. But log a to the power of b is equal to b into log a. So if you write formula for example log a to the power of b, given for example, we can write the formula b into log a. Same model you should write here, small t by capital T into, should write a log 2 is equal to log 100 you should write. So take a log 2 right side. Therefore small t by capital T is equal to log 100 by log 2. Oh sir, log 100 by log 2 should write. Here both for example base 10, no total meaning may not be changed. If both base e, we can convert into 2.303 will be cancelled. Now log 100 value, small t by capital T is equal to log 100 means a total 3 digits. So 1, 2, 3 digits. So 3 digits means a characteristic 2 point. Next, once if you choose the characteristic 10 value under 0. 10 value under 0 means all zeros only. First value. In logarithm book, first value 10 value under 0 all zeros only, divided by log 2 value. Log 2 value 0.3010 standard value. If you divide the value, that is equal to 6.64 something, will get a round off value 6.65. Take this as capital T also right side. Therefore small t is equal to 6.65 into capital T years. It is the time taken by the radioactive sample to reduce to 1% of the original value. 1% of the original value. Next question, 13.8. So check 13.8. the normal activity of living a carbon containing a matter is found to be about 15 decays per minute for every gram of carbon. If take 1 gram of the carbon, it has activity 15 decays per minute. In 1 minute it can emit 15 atoms. So initial activity given 13.8. Initial activity, I'll write a symbol R naught is equal to 15 disintegrations per minute. I'm writing a short form. DPM indicates a disintegrations per minute. In 1 minute, 15 atoms will be emitted by the carbon every 1 gram. Now, this activity arises from the small proportion of a radioactive carbon C614. Now present with the stable carbon isotope C612. So actually stable isotope carbon C612, but C614 is a radioisotope used for carbon dating. So to find the age of the fossils collected by archaeology departments. Now when the organism is dead, whatever the species, like or whatever organism, for example virus or something, a bacteria or maybe dinosaur, something, any organism for example dead, then what will be happen? The interaction with the atmosphere will be automatically ceases. Whenever the organism dead means the total activity will be stopped, and interaction with the atmosphere also it will be stopped. Then what will be happen? Ceases, and its activity begins to drop from the known half-life of the carbon C614. So they given half-life of the carbon 14 5730 right here. Capital T is equal to 5730 years. That means after 5730 years also still carbon contain half of the atoms. With this half-life, we can estimate the approximate age of the organism, and that method is called as nothing but carbon dating. Suppose a specimen from Mohenjo-daro gives an activity of 9 decays per minute. So archaeology department, they collected some species or some organism, dead organism in Mohenjo-daro and Harappa, and they observed it is having a 9 decays per minute. So activity after some time is equal to 9 disintegrations per minute per every 1 gram. Then estimate the age of the Indus Valley civilization. So generally in Mohenjo-daro and Harappa, so there will be Indus civilization there, and approximately how many years ago they lived, the people, we have to estimate. So small t question mark. So the question appears to be around 7-8 lines, but after reading we have to understand initial activity of the carbon given, that is equal to 15 decays per minute, and after some time whatever the species we collected in the Mohenjo-daro, it is having activity 9 decays per minute, but a half-life of the carbon 5730 years. Then estimate the age of the Indus civilization in Mohenjo-daro, that you should calculate. Note down this data. Now we have to apply R is equal to R naught into, formula is there, 2 to the power of or R equal to R naught into e power minus small t by capital T, or R is equal to R naught into e power minus lambda t. Also we have the formula. I'll use the formula here. Activity R is equal to R naught into e to the power of minus lambda into t. It is similar to number of atoms. N is equal to n naught into e power minus lambda t. Same way. Similar model I am taking, or on simplification we will get the formula. Small t is equal to 3.323 into capital T into log R naught by R base 10. In your notes, in a formula list already I have given this one. How we will get this value means you should take R naught left side. R by R naught is equal to e power minus lambda t. Taking a reciprocal on both sides, e to the power of plus lambda t is equal to R naught by R. Take e left side, that is equal to log base e, and log base e we can write 2.303, we can write, and then lambda place we write 0.693 by capital T. On simplification we will get this formula. Now we write 3.323 into capital T already given 5730 into log R naught is equal to 15 by R is equal to 9 base 10 you should write. That is equal to 3.323 into 5730 into log base 10, check this value, 15 by 9, 1.6666 or round off to 7. So this value we have to check in logbook. 3.323 into 5730 into, here before decimal point only there will be one digit. One digit means it is equal to 0. So what you have to check in logbook 16 value under 6 and the mean difference under 7 you have to check. 0.2216. Now multiply all these values. Total value, no? Total, all the three values multiply. 4219.43. So we have to check the textbook answer, or may take a logbook and check carefully. 13.8, question number 13.8. What they given? 4224 given. So this value how to check? 15 by 9. So this value little bit you have to check from logbook. Correct? I am getting 2216 are. So if you have the logarithm book, you should take the logbook and you have to check like this. Here 0. Okay, 16 value we have to check under 6 and the mean difference also under 6 you have to check, or round off this value to 7 also. Okay, so right here 7 also we can write like this. Log 1.667 also you can check. Here is under mean difference under 7. So this value plus this value both you should add. Whatever we got that you should write here. 4219. So I think in textbook they given in textbook they have given 4 to 24 years given. 4 to 24 years. So later may take logbook and write this value. Check after checking this value we should write here. Here this value how much you are getting? Log 1.667. 0.2216 still is there? 1.8. Then multiply. If you have the logbook, easy only to check the logbook. Already I have mentioned how to see the value. That is equal to 4 to 3.24. Or if you round up the value approximately 4 to 24 you will get. So while solving the problems, better to keep your log book also. Then it will be easy to check the logarithm value. So 1 or 2 digits may be varied, no problem generally. Now, so from this what we can understand means in Mohenjo-daro around 4223 years back, so Indus civilization existed. That you should check. Now 13.9, ninth problem. Check ninth problem. Obtain the amount of cobalt 2760 necessary to provide a radioactive source of 8 millicurie, MCI given millicurie strength. The half-life of the cobalt given 5.3 years. Write the data. Half-life of cobalt capital T is equal to 5.3 years. but here you should convert the value into seconds. So beginning already I mentioned 1 year is equal to how to convert 365 days into 24 into 60 into 60, or in textbook starting one value already I have given data 3.154 into 10 to the power of 7 seconds per year. 1 hour, 1 minute is equal to 60 seconds. 1 hour, 3600 seconds. And also 1 day, 86,400 seconds. 1 year, 3.154 into 10 power 7 seconds. If you remember the value, directly we can multiply. If you are unable to remember, no need to bother. So directly write 1 year is equal to 365 days into 1 day equal to 24 hours into 1 hour equal to 60 minutes and 1 minute is equal to 60 seconds. Like so, we have to calculate. Now multiply this value. 16.716 into 10 to the power of 7 seconds you should write. That is a half-life. Now, activity of the sample given. Activity of the sample R is equal to 8 millicurie. They are given like this. But curie is not SI unit of activity. Becquerel is the SI unit. We should convert the value also. 8 into milli, 10 to the power of minus 3. 1 curie value 3.7 into 10 to the power of 10 becquerel or disintegration per second. It is already in activity I have given 3 units. SI unit becquerel and practical units curie and Rutherford also given. Now multiply this 8 into 3.7. 29.60 into 10 to the power of 7 becquerel or disintegration per second. That is activity of the sample. Now cobalt given mass number. Cobalt having a mass number A is equal to the given 60. Then how much amount of the sample is required? So M should calculate, mass should calculate. So from activity formula, activity of a radioactive sample R is equal to, there is a formula lambda into N. Rate of disintegration is called activity and the formula you should write lambda into N. But we know lambda formula 0.693 by capital T. So half-life formula is there. T is equal to 0.693 by lambda or lambda is equal to 0.693 by capital T. Same way, how to find number of atoms in a sample? I have given Avogadro hypothesis. According to Avogadro hypothesis, total number of atoms in m grams of the sample is equal to Avogadro number into formula Avogadro number into mass of the sample by mass number. In the formula list, already I have given this formula and I asked you to tick this formula also because it is important. In exercise, 2 problems given based on this one. In this formula, what they are asking? What is amount they are asking? Means mass. M is equal to, take all the values left side, R, A, T divided by 0.693 into, next what you should write, Avogadro number Na. I think in notes already given this formula, the formula list already given, and while reading also numerator RAT is there. Now substitute the given data. It is important problem for 5 marks numerical. It is in textbook 5 marks numerical. In a PU level 2, 3, 4 times this question, this type of model asked. So if you have any doubt why we have written A equal to 60 in the question they given cobalt. So they given for cobalt CO atomic number 27, mass number 60. So I have written A equal to 60. Now I will substitute the value. M is now I will write M is equal to R value 29.6 to 10 to the power of 7. R value 29.6 into 10 power 7 into A 60 into T is equal to the given 16.716 into 10 to the power of 7 divided by 0.693 into Avogadro number 6.023 into 10 to the power of 23. First you should multiply numerator value. Numerator value 29.6 into 60 into 16.716 2968 7.62 we can round off divided by these two 4.17 means round off to 4 into 10 to the power of 23. Now divide these two values. Check the calculation carefully. If any one mistake is there, the total answer will be wrong. $29.6 into 60 into 16.716. 711.6 in okay into 10 to the power of 23 minus 14 minus 9. If you take a 23 numerator, it becomes minus 23 plus 14 minus 9. Adjust one digit. If you adjust or adjust 3 digits, if you adjust 3 digits means what will get 7.1126 into 10 power minus 6. Or we can write 711.26 into 10 to the power of what will get minus 8. What? Check how much given. Here 1, 2, 3 digits. If you want to adjust, 10 power minus 6 will get. Correct? 10 power minus 6, your choice. That depending upon your choice only. For example, if you write 7.1126 means round off to 3 into 10 to the power of minus 6 grams. 7.113 approximately 7 grams. 7.113 into 10 power minus 6 gram. It is a 13.9 and check the textbook answer what they have given. 7.126 nearly same only into 10 power minus 6 grams given. Correct. Or round off to 7.12 nearly. If you want to convert into kg, 1 gram is equal to 10 power minus 3 kg. Then you can write here only 7.113 into 10 power minus 9 kg. Correct. Your choice. That's the answer. It is a mass of the sample required. Next, 13.10. It is also important problem. Half-life of strontium is 28 years. Next question. So similar this question only. Whatever given, same model question. Just numbers only different. Process same. 13.10. 13.10 strontium given SR mass number 90. So obtain strontium, the half-life of strontium, that is a 38 atomic number, mass number 90. So here you should write A is equal to 90 and the half-life of this strontium given T is equal to 28 years. The given that is called 28 years. You may convert this value into seconds. 28 into 3.154 into 10 to the power of 7 seconds. That is equal to 88.312 into 10 to the power of 7 seconds. That is a half-life of strontium. Now, what is the disintegration rate of 15 milligrams of this isotope? Mass they only given. we should write mass m is equal to 15 milligrams, which is equal to 15 into 1 milli, 10 to the power of minus 3 grams, you should write. So we can maintain grams only. Why we have to maintain grams means Avogadro number we are taking 6.023 into 10 power 23. Now we have to estimate the rate of decay. Avogadro number we can write directly, already known value. Avogadro number 6.023 into 10 to the power of 23. Use this Avogadro number. So formula same, but last step just modification required. Directly we have to substitute all the values in this formula. Now substitute the value. R is equal to 0.693 into Avogadro number 6.023 into 10 to the power of 23 into mass of the sample 15 milligrams, 15 into 10 power minus 3 divided by denominator value 88.312 into 10 to the power of 7 into mass number 90. Numerator value 62.609 into 10 to the power of 20 divided by 7948.08 into 10 to the power of 7. Now take 10 power 7 to numerator. That is equal to 20 minus 7 is equal to 10 to the power of 14. 0.007877 into 10 power 14. Adjust the digits 7 point if right. 7.877 into 10 to the power of 1 to 3 digits means 10 power 11. Or we can write 0.78 into 10 power 10 also, okay, your choice. If you want to write a 0 point also, right, that is equal to becquerel. 7.877 into 10 to the power of 11 becquerel. Or if you want to convert into Curie also. So in textbook they are given 7.877 into 10 power 10 becquerel or 2.13 Curie also given. But no need to write exam in exam Curie. We can stop here also. Or if you want to convert into Curie, R is equal to 7.877 into 10 to the power of 11 by 1 becquerel is equal to 1 by 3.7 into 10 to the power of 10. So check the value, correct? 00 correct? Correct. 7.877 in textbook directly they given 7.877. 7.877 into 10 to the power of 10 becquerel given. Once again, one more zero is there, I think 0.000. Check this calculation. This calculation, we have to get this value. Here not 14, this value 13. Sorry, 13. 20 minus 7 should write 13. Here you should write 10. Correct? 10 you should write. Here numerator value 20, denominator value 7. If you take 10 power 7 to numerator, 10 power minus 7. 10 power plus 20, 10 power minus 7 is equal to 10 to the power of 13. If you adjust the digits now, 7.877, 1, 2, 3 digits, 13 minus 3 equal 10 power 10, becquerel correct one. If you want to convert the value into Curie, then we have to cancel 10 to the power of 10 and 10 power 10 is equal to 2.13 Curie. CI indicates a Curie. Exam both no need to write, anyone, SI unit enough. Next, these two questions, take the questions carefully, 13.9 and 13.10. If in syllabus, if it is not deleted, you should practice both the problems. Important for 5 marks, numericals. In a PUC syllabus, if PU board deleted radioactivity, no need to practice these questions. Depending upon the final syllabus, we have to follow. If syllabus not deleted, both the problems are very important for 5 marks. If a syllabus is deleted, no need to practice. That is only 13.8 and 9, 10. Next question, 13.11. 11th problem. Obtain approximately the ratio of the nuclear radii of the gold isotope. So they given a AU, atomic number 79, mass number 197. So for gold, atomic mass number A1 is equal to 197 mass number. And also second one they given silver isotope Ag with atomic number 47, mass number 107. So second one A2 should write 107. Then they are asking what is the ratio of R1 is to R2. Should calculate. It's a 2 marks problem. We know starting properties of the nucleus I have given, like nuclear charge, nuclear size, nuclear mass, nuclear density given, and the radius of the nucleus R is equal to formula R0 into A to the power of 1 by 3, one formula given. R equal to R0 into A power 1 by 3. Here R0 is a proportionality constant. So R proportional to A power 1 by 3. Here R0 constant. Then we write R1 by R2 is equal to A1 by A2 whole to the power of 1 by 3 should write. Since R0 is a constant. Only should write R1 by R2 equal A1 by A2 whole to the power of 1 by 3. A1 197, A2 107 whole to the power of 1 by 3. 197 by 107. 1.841 whole to the power of 1 by 3 means a cube root of 1.854 you should calculate. Cube root of 1.854. If you are directly if you are unable to calculate, you have to use log 1.23. So how to calculate the cube root if indirectly we are unable to calculate means you should take a log 1.841 whole to the power of 1 by 3. You should take equal to 1 by 3 into log 1.841. It is a method. That is equal to 1 by 3 into 1.841 value, logarithm value. We should take 18 value under 4 and mean difference under 1. 0.2650. Still is there any value? Okay. Then divide this value with the 3. 0.2650 divided by 3. 0.088. 0.08833. So here this value you have to check in anti-log. In logarithm book only, next page anti-log is there. Anti-log of this value we have to check. If you have the logarithm book, later how to check the logarithm anti-log means First page we have logarithms. Second page, if you turn the page, we have anti-logs. In anti-log, they will give directly 0.00 like that. Means first two digits, 0.08 value, first we check under 8. And then mean difference under 3. Add both. We'll get whatever we got. After one digit, you may put the decimal point. Here 0 is there before the decimal point. If a 0 is there, add 1 and then put the decimal point. If a 0 is there means after one digit. If a 1 is there, after two digits. If a 2 is there, after 3 digits, you have to put the decimal point. Last, whatever you got, that you should write here. So that is a 13.11. They given 1.23 given. I am writing here. Later, me check and write. So here, if you write the value 1.23. So that means the radius of gold. Radius of gold is 1.23 times that of the radius of the silver. That's the meaning. Radius of the gold is 1.23 times more than that of the radius of the silver. In exam, no need to show this value, but in a bracket, I may note down this one. How to calculate cube root. So directly, for example, 27 is there, write 3 cube, whole power 1 by 3, 3 cancelled. 2 cube, 8 is there, you can write 2 cube. 27, 3 cube, 64, 4 cube, 125, 5 cube, like that you can calculate. If it is not possible, you have to use logarithm like this. Next, 13.12. 12th question. Find the Q value and the kinetic energy of the emitted alpha particle in an alpha decay of 2 process given. Should calculate Q value. In notes, I think we have discussed what is a Q value, what is a exothermic reaction, what is a endothermic reaction we have given. In exothermic reaction, Q value positive, endothermic reaction, Q value negative, like that given. While finding a Q value, Q equal mc square formula, delta m into c square. Now first one, A. Alpha decay of radium with atomic number 88, mass number 226. Alpha decay of radium with atomic number 88, mass number 226. How much Q value will be emitted, they are asking. For that, I'll give the data. Should write first mass of radium Ra 226 and also mass of alpha particle also should write. Find the Q value and the kinetic energy of the emitted alpha particle in alpha decay of this first one. And they given mass of the radium given and the mass of radon also given. Mass of radon they only given Rn 222. Now write these values. First value 226.02540. 226.02540. Alpha particle mass in textbook starting given that is called 4.002603 AMU. And the mass of this one that is called 222. Mass of radon 222.01750 AMU. Now you should calculate the Q value of the reaction and also kinetic energy of alpha particle. Both you should calculate. That's the question. B also given, but later we'll calculate. First we'll calculate A part. Here no different formula you have to follow. Einstein mass energy equation E equal mc square formula only you have to follow. If atomic mass unit given, delta m into 931.5. First I write the equation. Radium Ra 88 to 226 emitted one alpha particle. After emission of alpha particle means you should write here helium 2He4. Here, whenever a radioactive sample emits one alpha particle, its atomic number reduces by 2. 86, 80 minus 2 equal to 86. And the mass number reduces by 4. 226 minus 4 is equal to 222. Then this will be called as a radon plus some amount of energy emitted, which is called Q value of the reaction. That Q value should calculate. I'll calculate first one. Q value of the reaction. Q value of the reaction is equal to delta M into 931.5 mega electron volt or million electron volt. But delta M means what? Always no need to follow ZMP plus A minus Z into Mn like that. So mass of the reactants minus mass of the products. Mass of the reactant means mass of radium, should write here. Mass of radium 226, left side reactant, right side both are called products, minus mass of radon Rn 222. Next, if you open the bracket means it is also minus 1, you should write. Mass of alpha particle into 931.5 MeV. So if you want to put in a bracket, if you for example here if you open the bracket, you should write both, you should add mass of the radon plus mass of alpha particle, both are products. After adding these two, we have to subtract from this one. That is equal to 226.02540 minus 222.01750 minus alpha particle 4.002603 into 931.5. That is equal to 226.02540 minus, first add these two numbers, minus x equal to minus 2x, correct? Both numbers minus means you should add, both minus you should add, that equal to minus x equal to minus 2x. Same way we should add these two minus values, but your choice. First from this one you have to subtract this value and then you may subtract the next value also, your choice. 226.020103 into 931.5. Now subtract these two numbers. I think you understood. If you open the bracket here, plus, if you close the bracket, if you open the bracket, it is a minus. 0.005297 into 931.5. The obtained value we have to multiply with 931.5. 4.93. Okay, 4.93 MeV. And one more they asked, kinetic energy of alpha particle should calculate. In that kinetic energy of alpha particle, Ke alpha is equal to, so in notes I have given on formula, check that formula. Last in formula list, Ke alpha given, the Q value of the reaction or directly in middle part, Q value of the reaction given last. Nuclear reactions, alpha decay, beta decay, gamma decay. In that part, Q value of the reaction exothermic, endothermic. Before formula list I have given, means in terms of the A given, A minus 4 by, they are all given, Ke alpha is equal to MD by M alpha plus MD into Q. So this formula given actually, but in or here mass, here you should write A minus 4, direct formula. A minus 4 by A into q, we can write the formula, direct formula. In notes already I have given, simplification also given from law of conservation of momentum. So it will be easy for you. But here also you can follow this one, but lengthy calculations you have to substitute here, lengthy values. Instead of that, I'll take a minus 4, a value 226 minus 4 by 226 into q value already obtained 4.93. That is equal to 222 by 222 into 4.93 divided by 226. 4.84 MeV. It is the total kinetic energy carried by alpha particle. But how much amount of energy released? 4.93 MeV. Out of 4.93, most of the energy was carried by alpha particle, 4.84, and the rest of energy, very less value, carried by residual nucleus, nothing but radon. That's only first one. Next, in this second question given, second B. In this only second question, I'll take. So time up now. Okay, second B question is there. We will discuss in the tomorrow class. Correct. Okay, thank you.